It is estimated that there are over 20 billion IoT devices nowadays, and that 127 new devices connect to the internet every second. Most of us feel it in our everyday private lives, but the real impact can be seen in businesses, where it boosted efficiency and brought huge cost savings. From IP cameras and smart elevators to patient monitors, MRI machines, and industrial control systems, critical processes are dependent now on connected devices. But connecting IoT devices to your network extends the attack surface and adds entrance points for hackers to target. Enterprises are exposed to corporate spying and threats to employee safety. Healthcare organizations are worried about patient safety and confidential medical files being stolen. Industrial operations in manufacturing and critical infrastructure facilities being disturbed for ransomware, crypto mining, and even terrorist purposes. Clearly, it is time to take action and protect IoT the same way we protect IT environment. Securing IoT devices is a challenging task. These devices are inherently vulnerable. They are built with no security in mind. Most IoT devices are shadow devices. Their activity remains unmonitored as they are connected to the corporate network without anyone's knowledge. And while IoT environments in enterprises are growing increasingly complex, IT security solutions have remained far behind. Checkpoint enables you to close the security gap with a cybersecurity built for IoT. Checkpoint offers the industry's most comprehensive cybersecurity solution for different IoT environments, including smart office, smart building, industrial, and healthcare. The solution enables organizations to prevent IoT-related attacks and minimize their IoT attack surface, all in a way that is easily scalable and non-disruptive to critical processes. How does it work? IoT real-time risk analysis exposes all the risks related to your IoT devices. IoT auto-segmentation automatically generates and enforces a policy for every device. IoT threat prevention blocks known and zero-day IoT attacks. Clearly, it is time to take action and protect IoT the same way we protect IT environment, with a cybersecurity built for IoT.
And many thanks for joining us. By way of introduction, my name is Marcus, and I'm the country manager of Checkpoint Singapore. So we have prepared some interesting and hopefully compelling content on Internet of Things to share with you. The Internet of Things actually refers to the billions of physical devices around the world that are now connected to the Internet, all collecting and sharing data. So connecting up all these different objects and adding sensors to them brings a level of digital intelligence to devices that would otherwise be dumb, right? Enabling them to communicate real-time data without the involvement of a human. So the Internet of Things actually makes the fabric of the world around us a lot more smarter, a lot more responsive, and it actually merges the physical and virtual universe. As with any technology, IoT has its own set of security challenges. Namely, the bulk of the IoT devices that we see nowadays has got weak credentials, easily guessable passwords and usernames. And the very nature of their deployment makes patching very challenging for this fleet of IoT devices, thereby exposing them to vulnerability attacks. And just the sheer number of IoT devices out there in the world right now means that there's always a possibility of misconfiguration, leaving a backdoor open in which then a malicious actor can access your IoT environment. And very often we do not have the full understanding or the full visibility of the IoT assets that we have deployed within our own networks. Now, together with ARMIS, We will be sharing with you today our observations on the IoT threat landscape and how we can improve the security posture and minimize the attack surface of the IoT environment. With that, I will hand over to Isaac, Checkpoint's Product Manager for IoT Security.
Okay, thank you, Marcus, and hello everyone, and good afternoon to my dear fellows in Asia Pacific. I'm sorry that I'm not can come and present it in Singapore during those crazy days. I really love Singapore. Been there several times, and definitely it's an amazing place to be in. So thank you for getting and joining this webinar. Let me just share my presentation. Okay, so I'm sure that all of you will agree with me that IoT is one of the biggest trends that we are seeing in the market today. The numbers are really huge numbers. In some reports, you will see numbers such as 25 billion IoT devices that we're expecting to see in the coming years, and with a growth rate of 20% every year and so on. But I think the important thing to remember is that already today, we are facing a huge number of IoT devices all around us, and focusing specifically on enterprise networks, on our office buildings, on our corporate facilities. We are already today seeing a huge number of IoT devices that are connected to our network. Now, think about it. You get in to work in the morning and entering the building parking, let's say, with your car. Probably you will notice a car license plate camera that is connected to the internet. Now, you enter in the building lobby and you will face card readers and lots of surveillance cameras. We have, of course, smart elevators, air conditions with smart thermostats, motion detectors, smart lighting devices, safety devices, everything is connected. Now, you're going into the elevator and going up to your office, entering the office, and also here you will notice many IoT devices. We have printers, IPTVs, IP phones, huge number of IoT devices, and everything today is connected to your enterprise network. Now, when looking at the enterprise IoT environment, our researchers found out that there is an average of 4 devices per employee. As I said, we are talking about a huge number of IoT devices. This means that, for an example, in a typical enterprise of, let's say, only 5,000 employees, you will find around 20,000 IoT devices. And those devices are very diverse. There's no single type of device. For each of those devices, you will find its own and unique characteristics on operating system, application, functionality, and so on. Many types of devices. And we have also many types of proprietary protocols, IoT protocols, BACnet, Modbus, it can be SCADA. And all of those diverse devices and all of those diverse protocols are now connected to our network, to the enterprise network. Now, it might be that some of those devices are also connected to the external internet. It can be because of, let's say, maintenance issues. We would like to enable the vendors of those IoT devices to be able to upgrade those devices, to make sure that they're always running the latest available software. Or it might be because we are using a third-party building management service who have control over our building. They're maintaining in our building services. Now, when looking at the entire IoT environment, we need to remember that it is not only about the IoT devices themselves. We have also many other systems that are connected to those IoT devices. We have servers, we have workstations, we have many users who are using those IoT devices. It can be building management system for managing those devices. It can be, for an example, a DVR that sits in your data center, and we are using this DVR to get and to record the feeds from the video cameras and so on. Now, probably the most important thing that we need to remember is that those devices are unmanaged devices. It means that they are connected to our network, but in many cases, you will not find them in your existing IT management and security systems. If you will look for them, they are not there. You will not find them, but they are connected to your network. Now, those devices are also really great, and we can talk on one side on increasing the operational efficiency of your business or moving to the digital workspace and so on. But on the other side, we need to remember that those devices also create a huge attack surface for cyber criminals to come and to hack into your systems, into your networks. Check it out. A few months ago, a survey that was published by our good friends from Armis and Forrester, they found out that 67% out of the enterprises have experienced security incidents that is related to their IoT devices. 74% said that their current security controls are not suitable, are not designed to handle the IoT devices. And 90% said that they have shadow IoT devices inside their enterprise network. As I said, those devices are connected to your network, but you will not find them in your existing IT management systems. Now, the cyber attackers can access those devices, and they can do that quite easily. And they can do that from two places, starting with the internet. Many of those devices are connected to the internet, and in many cases, they are connected using insecure connections. It can be because of misdesign, misconfiguration. We might be using the wrong protocol, the wrong port. So the attackers who are using standard attacking techniques, you don't need to be so sophisticated, such as malicious domains or scanning the internet, can find those devices quite easily and can get access to those devices. For example, if you will go to Shodan website, I'm always sometimes referring to it as the Google of the IoT hackers. And you will search in Shodan, for example, IoT devices like say webcams or building controllers. Probably you will find thousands of IoT devices that are connected already today to your enterprise, to the general enterprises globally, I'm talking about, of course, and also to the internet. So you can search for those devices using Shodan website. Now, the attackers can also access those devices directly. Think about visitors, employees, technicians, and anyone who can walk through your facility, through your building. Do they have access to those IoT devices? Can they go and connect to those devices directly, maybe using a USB port or Ethernet port? You can sit in the lobby of the building and search for open Wi-Fi networks. Probably you will find some. And the question is, how many of the IoT devices are also connected to those open Wi-Fi networks? Or again, you have access to those devices. Now, once the attacker manages to access to an IoT device, it is very easy to hack into the IoT device itself. Most of those devices don't have even basic security capabilities. Many of those devices are based on outdated software and legacy operating systems. And many of those devices are based on default passwords. Now, think about it. Have anyone here ever changed a default password in one of the IoT devices that you have inside your network today? Probably not. We are talking about hundreds and thousands of devices. Now, those devices are also very hard to patch. We have many limitations that preventing us from going and changing the software inside those devices. Limitations such as physical access, devices that need to work 24/7. And in many cases, those are just simple, unmanaged, invisible devices that are connected to our network, but we don't have any way to control them. And the attackers, they know that. And they're using those IoT devices. They're using them in two ways. The first way is hacking into the IoT devices themselves and then manipulating the device. It can be, for an example, let's say a simple security camera that you have inside your building. And the attacker can take control over this security camera, or maybe to put a bot inside and to add it into a botnet attack. This is very common with IoT devices, or maybe to use it for crypto mining. The second way the attackers are using those IoT devices is as backdoor to to your corporate networks. Because in many cases, those devices are, as I said, connected to your network from one side, and to the internet, they are connected, and many times insecurely, on the other side. Only a few months ago, Microsoft published that they found out that the hackers group from Russia, known as APT28, are using those IoT devices. They're using printers and IP phones that are based on default passwords in order to get into enterprise networks. I'm sure that all of you are familiar with Mirai attack. Back in 2016, targeting hundreds of thousands of IoT devices. Now, a few months ago, IBM published that they found out, only last year, 60 new variants of Mirai attack, and it seems that they are targeting now specifically IoT devices inside the enterprises. Now, interesting thing to see is that if we are looking into the scripts of those attacks, and you can see it here on the screen, we managed to get those scripts. Already today, we have a good method to identify the infected devices. Using checkpoint security controls, we can identify the malicious address that the device is trying to connect with. You can see it here. We can identify the bad URL, the CNC address that the device is trying to connect with. And of course, using checkpoint security controls, we can identify it and block this communication. Zigbee systems becoming to be very popular with smart buildings. Zigbee is a wireless protocol that is very efficient for managing large number of smart devices. In a typical Zigbee system, you will deploy on one side, as you can see here, the Zigbee gateway that is connected to the corporate network. And on the other side, you will deploy a large number of devices that can be controlled through this Zigbee gateway. A very popular Zigbee system is for smart lighting. You can control remotely thousands of smart light bulbs across the entire building. Now, few months ago, our researchers from Checkpoint, they found out that you can hack quite easily into the Zigbee system using a very simple method. The only thing you need to do is to simulate a Zigbee device, and you can do that in your laptop. And by doing so, you will get access to the Zigbee controller, and then you can, for example, put a malware inside this controller. Now, think about the next scenario. You can sit in the lobby of the building, let's say a large bank. The only thing you need to make sure is that you are in the range of the wireless Zigbee network. And now you can hack into the system. And you can, for example, turn off all the lights across the entire building. Or maybe use this controller in order to get to other systems inside the corporate network. This is a typical architecture for a building controller that I've taken from one of the vendors who developing and manufacturing this device. The device is connected to all the systems inside the building and providing you full control over all of those devices and systems, the building systems. Now, you can access this device using a remote, mobile, or web access, and you will get very impressive dashboard and monitoring and management tools for controlling the entire building. Very impressive. Now, a few months ago, US Homeland Security, they published a critical risk for this device, giving it a severity score of 10. This is the highest severity score. They found out that there is a backdoor inside this device that enables the attackers to hack into it, and they can do it from the web and to gain full control over the system, meaning that they can gain full control over the building. Now, of course, the vendor immediately they released a software update for this device, and immediately they called all of the customers to go and update the software inside this device. But the question is, how many devices are still out there that have not been upgraded yet? Or how many other controllers from other vendors have similar vulnerability that enable to access them from the web and to gain full control over your building systems? So the question is, okay, so what now? What should we do? you have a huge number of IoT devices inside your network that are connected to your network, to your building. Those devices are very easy to access. Those devices are very easy to hack into. And those devices are unmanaged devices that are invisible to your existing IT security solution. And when our team sat down in order to solve this problem, we first defined two mandatory security functions that we would like to achieve. The first security function is to prevent unauthorized access and malicious intents from reaching those IoT devices. In simple words, if someone trying to connect to a device, but he is not authorized user, we should block this communication. If a user trying to communicate with a device, but using the wrong protocol, we should block the communication. And if malicious traffic tries to get to a device, we should block the communication. Now, the second security function is based on the fact that you might already today have infected IoT devices inside your network. And we should accept this, since we are talking about thousands of unmanaged devices that you have already today inside your network. And it might be that some of those devices are already infected devices. So we would like to identify those devices and to isolate them, to prevent them from compromising other devices and network elements. Our solution consists of three components. The first component is IoT discovery and risk analysis. We would like to start by finding all the IoT devices that you have inside your network, and to classify those devices, to tell you exactly what type of devices are those, what type of vendors this device is, what type of vendor, what operating system is it using, what firmware version is it using, and so on. And we would like also to analyze the risks that those devices poses inside your network. For example, this device is connected to the wrong port, it's using the wrong protocol, there is a known vulnerability for this device. It might be using outdated firmware that you need to take into consideration and update it, and so on. So it is about creating a full intelligent map for all the IoT devices inside your network. The second component is IoT policy management. We would like to apply a granular policy that will tell exactly for each of those devices what it can do and what it cannot do inside your network. What IoT traffic is allowed and what IoT traffic we should block. And the third component is IoT threat prevention. We would like to identify and block IoT malicious traffic before it reaching the IoT devices. Now, it is not only about the IoT devices. As I said before, we need to think also about the servers and the users and the workstations. So we would like to protect the entire IoT environment. Protecting those servers, protecting those workstations, protecting the users who are connected to those IoT devices, and we can do it using Checkpoint threat prevention engines. So we would like to start by identifying every IoT device inside your network. And in order to do so, we've developed a unique API that enables us to collect any type of information from any IoT discovery engine. And we already today have a very good integration with many discovery engine vendors, and definitely Armis, who is here together with us on this webinar, have a great discovery engine. They are one of the leaders in the market, and they have a great discovery tool that automatically identify every device inside your enterprise network. Now, this discovery tool that is based on traffic monitoring, and then they are using advanced technologies such as deep packet inspection and device profiling, can tell you exactly what IoT devices you have inside your network, and to provide granular information for each of those IoT devices. This is an IP camera, this is the vendor, this is the operating system, this is the firmware version, IP address, MAC address, and much more useful information. Now, ARM is also analyzing the security risk that this device poses inside your network. As I said, they can tell you that this device still runs outdated software that you need to take into consideration because there is a security vulnerability that is related to this outdated software, and you need to take it into consideration and go and update the device. They also provide a really very intuitive dashboard, amazing asset management tools that you can use for real-time monitoring of all the IoT devices inside your network. And you can see only some of the screens here, and I'm sure that Armis after me, they're going to provide you a very nice presentation of that. Now, we have identified all the IoT devices inside your network. And the next step is to send this information to a Checkpoint security management system. And inside the system, we've added a component from Checkpoint side called IoT controller that enable us to configure security rules for those IoT devices. This is how it looks. So you can see on the top left side that we've created a separate IoT policy layer. This is part of a Checkpoint security management system. So you can see we've created a separate IoT security layer. And now using this IoT security layer, this IoT security tool, you can configure and manage security rules that are based on the IoT devices attributes. So you can see on the right side a list of all the devices, and in the middle we can start configuring security rules based on, let's say, the vendor type of the device, the functionality of the device, maybe the unique protocol, it can be BACnet or Modbus, and so on. And this is a very good example for one of those rules. This is a very common rule. We would like to enable all the IP cameras inside your building to be able to communicate with the VMS, with the video management server, only if they're using OnWith protocol. This is a very common protocol for IP cameras. And only IP cameras from Hikvision can communicate with hikvision.updates.com only if they're using HTTPS protocol that is common for doing firmware upgrades. So as you can see, now using this combination between the IoT policy manager and the IoT devices attributes that we get in from the discovery engine from Armis, we can, or you can, configure quite easily security rules that are related to those IoT devices. In most cases, we will configure security rules not for a specific device, of course, that we can do that, but in most cases, it will be for group of devices. It can be based on their functionality, based on the vendor type, and so on. So for example, you can configure one policy for all the IP cameras inside your building, another policy for all the printers inside your building, and another policy for all the HVAC systems that you are using. So the next step is to enforce the policy inside your network. And in order to do that, we need to deploy security controls inside the network, and those are Checkpoint security gateways. Now, the trivial place to start with will be at the perimeter, starting by controlling all the traffic that goes in and out of the internet. We will probably also deploy a security gateway in the data center, and we need to take into consideration that most of the traffic, the IoT traffic, goes between the IoT devices and servers in the data center. So we must deploy a security gateway in the data center. But this is not enough. And specifically when we are looking at IoT environment and IoT networks, we must consider internal network segmentation. And in order to do that, we are using internal segmentation gateways that we are deploying inside the network. Usually it will be in the distribution layer. And then we can use techniques such as inter-VLAN to implement different zones inside the network, and using those gateways to control the traffic flow between the different zones. So as I said before, it can be one zone for the security camera and one zone for the printers. Now, it is very important to notice that the Checkpoint security gateways, they are great for enforcing the IoT policy, but not only. And those security gateways are great gateways also to implement threat prevention engines inside your network. Those gateways are integrated with really the best available threat prevention engines that enable you to identify and of course to block malicious IoT traffic, both for known and unknown malicious attacks. And this is very important. Now, as I mentioned, one of the main challenges we are facing when dealing with IoT devices is that many of those devices are unpatched devices. They are running outdated software and missing security updates. And it might be that the vendor of a specific device is aware to a security flaw that this device have, and even released a suitable software update for this device in order to overcome this flaw. But still, as I mentioned, we have limitations such as operational limitations that preventing us from going and updating those devices. We can't go and change the software inside those devices. So this situation that we have devices and many devices inside our network with non-security vulnerabilities is very disrupting because we cannot go and patch those devices. We just cannot do that. And this is where our virtual patching service that is integrated inside our security gateways becoming to be very useful. We have a huge list of non-vulnerabilities that we are aware about. It can be related to specific devices, to specific protocols, to specific operating systems, and so on. And now, we know how the attackers are using those vulnerabilities and what are the attack patterns that are related to those attacks and what are the traffic signatures that we should look for. So we are using our security gateways to monitor the traffic and look for those specific signatures. And of course, that once we will identify such a signature, we can block it, and we can, of course, not block, we will identify the signature, but to block the malicious traffic. And you can see here a great example for non-vulnerability in Hikvision devices, and that we have activated inside our gateway the relevant protection to identify the signature that is related to those devices, to Hikvision devices. And basically, we're giving you the peace of mind to keep using those devices. Now, as I said, looking at the entire IoT environment, it is not only about IoT, it's not only about the IoT devices themselves. We have many other elements that are related to the IoT devices. We have servers, workstations, remote access, mobile access, and so on. Now, let's say that you've deployed the best, really the best protection in the world for securing the IoT devices themselves. But what if the workstation that is connected to those IoT devices have been compromised by a malware because the user opened a malicious email that you've got? Or what will happen if someone will access the IoT systems using an unsecure mobile device? Or what will happen if the user will connect to those devices from the web using a remote access using insecure connection? We know now in those very challenging COVID-19 days that many users are working from home and accessing those devices from their home. So what will happen if they will use insecure connection? And this is why we need to implement a comprehensive security that will protect all the elements inside the entire IoT environment. And this is one of the things that Checkpoint provides you, because we have all the security components that you need to deploy a comprehensive security that will cover all the elements inside your IoT environment. So putting it, everything together, these are the 6 steps that you need to implement in order to achieve a comprehensive IoT security. Starting with deploying a security perimeter gateway and making sure that you will block malicious traffic before it entering your network. The second step will be to implement virtual zones inside your IoT network. As I mentioned, it can be one zone for the security cameras, one zone for the printers, and so on. So we can use VLANs in order to do that, and of course, apply those VLANs to the right zones, and so on. The next step will be to deploy Discovery Engine. This is the Army's Discovery Engine, and we can monitor now the traffic, identify and classify the IoT devices inside your network, and send this information to Checkpoint Management System. So the next step will be to use our IoT policy management that is part of our management system in order to define access policy that is based on the IoT devices protocol, and this policy can be assigned, as I said before, for a single device, but also for group of devices. So we can define a policy for the security cameras, and another policy for the printers, and another policy for, let's say, the parking devices inside your building. The next step will be to enforce this policy inside our gateways. And as I said, it needs to be both the perimeter gateway and the internal security gateways. And we need to enforce this policy using our gateways. And the last step, step number 6, will be to use our threat prevention engines in order to identify and block malicious intents and malicious traffic that tries to get into your network. Okay. Thank you very much, and I would like to move now to Ben, who is the VP APAC for Armis, our very good friends. Ben, the stage is yours.
Thank you very much, Tzitziki. It's very kind. I think Prima, potentially, did you want to ask a few questions before we moved on? So Prima, are you, sorry, there's Prima as Paul. So if you just take a few minutes to actually, if you wouldn't mind just populating the poll for Prima to get some data, that would be much appreciated. And Prima, once you've got that, once you've got enough data, you let me know and I'll start my presentation. I think while this populates, I'll do my best to answer some of the questions that are coming through. And I've just seen one question specifically is, who's Armis? Are they specifically an OT sec company? I think just to give you a quick explanation that Armis was very much, designed from the ground up to be around everything. We don't just focus on a specific IT, OT, medical OT. We're designed to be anything that's connected. Basically, we're trying to give you visibility and control over through the integrations with the likes of Checkpoint. So I hope that helps, and there'll be a more detailed Q&A at the end of the session. Okay, so I guess before we move on, there's just looking at the results of the poll. Everyone seems to understand, what IoT is, what it's doing, and also starting to get across this whole new terminology of managed versus unmanaged devices. So there are still, some 20% that have said they don't understand. So I guess just to give a quick explanation is, if you can think of something that you can't physically put, a piece of software, an agent, or, you can't proactively patch, that's what we class as an unmanaged device. And unfortunately, I've been in IT for too long. I wouldn't want to give away my age, but I've been doing this for like 25 years plus. And what I really enjoy speaking about with this slide is it actually shows, an exponential, a massive growth, not just in IT, but, the days of just having a desktop. When I was, when I first started my IT, we had a desktop and a phone. And then the next big boom was, well, a laptop. How then can we protect a laptop or an iPad? But they're just things that, I can access personally, which are my device. Basically, you bring your own device. But then when we start to look past that and look to the next level, like if I think about my daily trip, pre-COVID, of course, when I wake up in the morning, one of the first things that happens in my house is I have smart lighting. My lighting is preset. If there's a movement or a sensor to, come on. And then, it may be my cameras, for instance, that then are IoT connected and are sending my movements to the cloud. When I leave my house and I go to my coffee, I swipe my card, and there may be a card or an IoT reader to be able to tell the barrister what I want and what I've had. I swipe onto the bus. Again, there's another reader taking my information, where that's, we call it no contact in this day and age, but that's feeding back into another big data or into a system that's actually measuring who I am, what I'm doing, and, why am I doing it? I get off, I may walk through the shopping center, and straight away there's cameras picking up who I am, what I'm doing, and where I'm going. I walk to my building, I'm swiping in, and then Itzik talked about it in his presentation. BMS is a huge part of where we're going. The building management, aspect of the enterprise network is becoming a large part of things we didn't traditionally think of. We look at lift, we look at HVAC, we look at so many things like access control, things that we never thought would be part of a corporate enterprise IoT approach. It's almost, it's bewildering just how much IoT is changing things. And as a result, what we try and predict, what we can't predict, what we're trying to depict here is just what the vast scale of these connected devices are. So if you look at 2010, as opposed to where we're going now in 2021 at 25 billion connected devices, like these slides are already out of date. When we talk to Forrester, we talk to Gartner, where this information is actually set from, we're looking at almost 30 billion devices. And that this is not a specific problem. This is a situation. As mankind evolves, we are evolving at such a rapid rate. And as evolution increases, the number of connected devices to keep us relevant and to keep our businesses productive and to keep our families safe, for instance, are just going to continue to actually soar. So, I think it's a great slide. From a business perspective, I think it's, almost bewildering to look at and to see just how quickly as humans we're evolving and how much, every single connected device touches our life. But, it's covered some of these, but if we look at everything from security cameras to medical devices, to the smart lighting, to manufacturing, to your home printer, to your office printer, we touch multiple wireless, access points on our way to our everyday work situation. It's just unprecedented. So what ARMIS was designed to do was to try and help give some level of visibility and, as much control as you can actually apply to these devices. So, traditional security is very important. Security purist, I've worked in security for 25 years plus, but the traditional security methods of applying software or an agent to monitor these devices, it's no longer relevant because we can't actually or physically push software to these devices. So the only way that we can actually start to look at this is visibility. You can only really protect what you can see, or you can only protect yourself from what you can see on the enterprise network. So, again, we're very thankful for the partnership with Checkpoint. We're only one piece of this puzzle, but what we feel like is we give Checkpoint a large amount of context around devices they wouldn't traditionally be able to recognize or see, and then allow them to do a sterling job around actually applying some control, some policy around actually taking some action from the information that we're providing. So in a nutshell, I guess the ARMIS was very specifically designed to fix a problem, and the problem is that as we evolve, the amount of connected devices is just going to continue to increase. And we just want to be able to give some, some assurance and some visibility to the enterprises, across the world. So what I'll do is hand over to Michael and to Zen, who are two of our senior solutions architects, who will actually take you through some more detailed slides and actually a very short sort of walkthrough of how we do this and how we integrate with Checkpoint. So thank you very much.
Hey, thank you, Ben. So I'm Chen Hong, the Regional Channel Sales Solution Architect. I hope everyone can hear me. So now let me show you how ARMIS and Checkpoint actually solve the problem that Ben mentioned earlier. So first, ARMIS actually discover every device in the customer's environment That include your managed, your unmanaged IoT devices, every devices that is communicating in the airspace via your Wi-Fi, your Bluetooth, your Zigbee. So Armis is totally agentless, passive, and cloud-based, and thus this makes us very easy to deploy and configure. So next, Armis actually compares every of these devices that we see real-time behavior to the normal behavior characteristics that are stored in what we call the Armis device knowledge base. And then we are able to assess the risk of each device and detect when the device becomes suspicious. So with our device knowledge base, which is the world's most extensive crowdsourced device knowledge base that we have, it actually tracks unique device details such as how these devices communicate with each other, what protocols, how much device is this transmitting, is this device usually stationary, what software is it running, so on and so forth. So next I will show how we works. So okay, so Armis first detects and discover all of the information available to a device. And next, we will do a risk assessment using information in our device knowledge base I've mentioned earlier. So then Armis actually use these device details and do a risk assessment and send them to Checkpoint IoT Security Manager. And then this Armis will also use this device to push policy recommendation to the IoT Security Manager. The administrator of that IoT Security Manager will be able to enable these policies, or they can even create the policies manually using the device attribute that we push to them. So with the IoT Security Manager, they actually applies this policy via the firewalls for enforcement. And these policies can be used as virtual patches for devices that cannot or not able to be patched. And if the device is too risky or even trigger an enabled policy, it will be quarantined or blocked. And in the event, which I mentioned earlier, unpatched or unpatchable devices, which most of the IoT devices are. So we are able to make use of what we call the virtual patches to make them possible to continue using them safely. So without further ado, I will actually hand this over to Michael, who will show you how Armis actually discover all these devices, and then how we actually push it over to the IoT Security Manager for them to do the enforcement part. Michael.
Thank you, Zheng Hong. Okay, so as you can see from this screen, this is the dashboard of Armis. So the first part in the whole process, which Zheng presented, was discovery, right? So we can discover all the devices here, and we also score the devices based on the risk of our from data from our knowledge base. So let's take a look at one of the devices. We drill down from here. Let's look at imaging. And I'm interested to look at IP camera with a rather high risk score. Let's see, I have a network camera here, which will have a risk score of 8. Okay, so you see in the previous slide that Zheng presented, we present all this detail to Checkpoint. Okay, the MAC address, IP address, manufacturer model, and all this information. And from this display, from this UI, you can see that we have an alert on this device, and this device is showing a botnet compromise of botnet in this device. So based on our knowledge base and our risk assessment, we're able to determine that this IP camera has been compromised. Then following on the next step, whereby we do the risk analysis, this part, let me pivot back to the first page. Okay, I want to look at some computers for managed devices. So let's take a look at this computer. This computer, you can see that here it's a laptop, Windows, and we provide you with all the vulnerabilities from our vulnerability database. And you can see that every vulnerability that is has been identified will be flagged out in this. And when you click on the CVE itself, it will go to the CVE website, and it's for you to look at it. And of course, we also profile the risk factors, okay? Vulnerability score, and all these risk factors here, okay? Okay, that's about it for the screen that I have. So this will be presented to a checkpoint, whereby they can do the enforcement based on that particular slide that we have, just to reinforce again, which is this slide. Okay, first we discover the device. We do risk assessment, where I show you the CVEs there, and we also do all the risk assessment and determine that some of them actually have botnet compromise. And we do some policy recommendations to Checkpoint, and Checkpoint will do all the virtual patching and all the enforcement. Okay, so I will pass on to Royce from here.
Hi, okay, thanks. Thanks, Michael, for going through. So let me just share my screen. Okay. Can you all see my screen? I think you all can. Okay, so before I start, today I've actually prepared a demo video that shows various scenarios of the integration with ARMIS, okay, discovery engine in this demo environment. So I will first show some parts about how Checkpoint can set up our IoT controller using some form of API integration, and showing all the assets and devices that ARMIS have discovered in our security management server. After that, I'll also briefly go through the automated creation of the IoT policy that the security management will actually perform. And also from there, I will demonstrate some very simple attacks from what you can see over here from the screen, from the attacker machine to the IP camera. And then finally, the last portion, I will just go through some logs and reports generated to showcase the entire IoT report and views, so on. So before I start the video and going through all the features and functionalities on how we integrate with ARMIS, let me just walk you through the environment that we have. So first and foremost, there are three networks here, right? 172.23.125 is for the IP camera, 172.232.51 is meant for the attacker machine, and finally we have 192.168.103 for the management and ARMIS discovery service. Okay, so let me just play this video and walk you through. The gateway for the enforcement and the management server has already been set up. So it's something called SIC, Internal Secure Communication. So we can do policy installation and so on. So the first thing to observe right now is when we go under RAD security management and filter according to 166, which is our attacker IP address, we are not able to see any logs as of now. Okay, so this is the current situation. Now let us do the very first part of things, which is to integrate with ARMIS via API integration. Let's see how it's done and how seamless it can get, right? So the first thing you need to do is to create a new IoT discovery service, right? Key in any name you would like. In this case, it's my discovery service. The host name of the IoT discovery server. The port that will be utilized, right? So 443 in this case. And then the pre-shared key that is provided from ARMIS. Do a test connection. You will be prompted to trust a certificate. Go ahead and hit trust, and then boom, you are connected already. So we can see this API integration is pretty seamless with ARMIS, right? So the next step we will want to do is to publish changes to make sure that these changes have been saved to the database of security management server in Checkpoint, right? Now let's take a look at the IoT controllers. If you notice, you will be able to see all the imported assets and device that has been discovered by ARMIS, right? And we can also do a very simple filter search. For example, right, IP cameras, to see what are the IP cameras that has been discovered, and so on and so forth. Right, so there are a lot of discovered assets and devices, and from the security management server, we are able to, you know, pull out all this. So the next thing that would be created automatically is the IoT security policy layer, right? So we get all this information from armies, we populate them into different rules. We have in here, for example of rules, right? Source could be from HMI, IP camera, and so on. And also, within this particular rule, we have something called the inline layers, right? Inline layers, basically what happened, let me just pause the video here and explain roughly what are inline layers. Basically, these rules, right, have to hit the parent layer before you can hit the below layer. They call it the inline layer. So all this has already been automatically populated from source, any, to destination IP camera, and with certain action in place. So these are all automatically created when API integration is being done. So let's do a simulation of attack right now, which is our third objective of this demo, right? So the simulation of this attack right now, do take note that at this moment in time, this stage, the policy that is populated has not been pushed to the gateway, right? So this is the before enforcement scenario. We can see that the attack reached the device, and then we do a refresh. We couldn't see any logs at all right now. This is the before enforcement. Now let me just do install policy to make sure that yes, although it's populated automatically, now I want to make sure that I push this enforcement to the gateway. So after installing this security policy that we have, with certain action that I have already put in place, we can simulate another attack right now with the enforcement on, right? In a sense, attack reached the device. Now let's do a refresh on the logs and monitors. We can from there see the different logs that has been collected from this particular attack from here, right? So from the source to the destination and what kind of service is being used. We can even filter from our logs to the name, like called IP camera, for example. And we have more details about all the logs pertaining to just the IP camera, not from the attacker sense. Okay, so the last part and the last objective of this demo is to showcase the capability for us to have views and reports of IoT generated kind of views and reports for you to have insights into all the devices and assets and what are the potential kind of suspicious activities and so on, right? So in this case, we are filtering for the past 7 days. We can have a look at the suspicious access to devices, for example, what are the services used, incidents over time, and even access details, right? To give you all the insights into these different activities for your IoT and assets and device. Okay, so I think this demo, I actually covered 4 major components, just to sum it up, which is the portion of, firstly, IoT controller in Checkpoint, API integration with armies. You can see how seamless the entire process is. We also showed you the automation creation of this IoT security policy for easy administration, right? You do not have to create one by one and so on. These are all discovered and then just automatically entered for you. So also we had demonstrated some simple attacks as well. And also finally, to go through what are the potential logs and reports that we can give you, right, from these findings. Okay, I think with that, I will pass my time back to the coordinator, right? Prima.
All right, we have some time for Q&A. Idzik, would you like to answer the questions in the Q&A panel?
Yes, please. Okay, so there are a few questions here. Actually, there's a long list of questions, but we've highlighted the important ones. So first of all, there's a question about what version is it working with? I'm guessing you are referring to Checkpoint management system. So the solution is already integrated in our R8040 version. You will note there is another question about the license. You don't need a separate license in order to activate it. So any customer who is using Checkpoint R8040, if you still didn't migrate, it's time to start thinking about migrating to R8040. And it is the IoT controller is already part of the R8040. In order to activate it, the only thing you need to do is to provide the IP address of the discovery engine. In this case, it's Armis, and everything else will be done automatically. You will need a separate discovery agent license, and you can get that also from Checkpoint or from Armis. Armis product is available on Checkpoint catalog. Another question here is, what are the most attacked devices? Okay, and what is the most popular attack? Okay, so this is an interesting question. My guess, we don't have formal numbers. Again, it's changing all the time. But what we are seeing is that definitely surveillance cameras, security cameras, those are really being attacked. I'm guessing it's because, first of all, there is a huge deployment of those devices. Most of them are based on default passwords. And the most popular attack is also related to those cameras is turning those devices into bots. Very similar to what we are familiar with the mirror attack. So basically what you are doing, you hacking into those, you don't even need to hack because most of them are based on default passwords. So you manage to get into those security cameras, most of them running Linux operating system. You can inject them, install a very small script and turn them into a bot in a botnet attack. The scary stuff here is that if you think about mirror attack was mainly around home devices, consumer devices, but think about what will happen if someone will manage to install a bot in all of the security cameras inside your enterprise, and it will be like an internal DDoS attacks against your own network. So you need to be very careful about that. Another popular attack that we're starting to see is crypto mining. We're starting to see more and more devices that are being turned into crypto miners. Again, we are talking about thousands of devices that are very easy to hack into. So you put it, they don't have lots of CPU power, but still we are talking about huge number of devices. So it's worth doing that from an attacker point of view. I have here a question for Armis. So Ben, probably it's for you guys. How do you monitor the traffic? And there is another question that probably related, and how can you identify the devices based on the traffic, and what type of devices can you identify? So I'm guessing this is for you guys to answer. Ben, you are on mute.
Yeah, what I'll do is I'll actually, I guess they're two very different questions. The first question is, what are we designing to? Literally anything that's IP connected, or even Bluetooth, Zigbee, a variation of different IoT communication methods. We're designed to monitor that. So if you can just I think the biggest thing is people think about IoT and they start to pigeonhole smart meters, smart grids. But we're literally designed, I can monitor your laptop and tell you what applications, and what behaviors and what you're doing on your laptop or the server. But at the same time, I can tell you what this PLC controller is doing that only speaks to this HMI for this amount of time per day. So it's literally anything that can communicate. We're working, monitoring, assessing, and then feeding to the likes of Checkpoint to take action on. But, Zen and Michael are here. They're probably better suited to be able to dig a little bit deeper if you want to add some context to that.
Okay, so yeah, so this is actually how our architecture looks. So first, we actually install a collector outband. So the collector can be connected via your span port or your tag, and then we also integrate with the WLC. So with all this, we can actually and it's like I mentioned, it's totally 100% passive. So we make use of your existing infrastructure to tell us everything we need to know. What is on your device, on and off your network, in your airspace, for example. Another integration, some of the integrations that we actually do is with the NAT, your SIM, your firewall, your checkpoint IoT security manager. So what happens is our collector actually sees a payload, and we strips out all the metadata and send those to what you see in the cloud there. So the cloud is what you have, the Army's threat detection engine, our analysis engine, as well as our device knowledge base. Everything is there. So once we analyze all these devices, we'll be able to push it to the checkpoint IoT security manager, as you see below. With that, we also provide you with the policy, recommended policies of what should be do. And you can actually enable them on this checkpoint IoT security manager itself. So this is how we actually look at all the traffic that's coming in your environment and how we actually do the enforcement part.
Okay, this is great. And I have here two more questions. So first of all, there is a question regarding our security checkup. Are we going to enable a security checkup for IoT devices? So the answer is absolutely yes. And together with ARMIS, we can, of course, get to a customer and do like a pre-installation service where we will see all the devices. You will get very nice reports. Ben, do you have any? Do you have a report that you can present now, or do you have something?
Not a report we can present now, but something we can share after. But like Isaac said, this is something that customers are very, very interested in, existing checkpoint or not, and we can work together very well to give you a high-level executive summary of what's actually on the network and what you should actually be paying attention to.
Yeah, and definitely it's going to be part of the security checkup. And as Ben said, basically what we are doing, we coming. It can be a virtual appliance. You don't even need to get a hardware appliance from our side. It's only a virtual component, monitoring the traffic, and you will get these very nice reports. Very impressive, by the way. You will see all the devices, all the security flows, everything. Another question is, okay, this is an interesting question. How can I identify CCTV devices, hacked CCTV devices? So the question is not only about CCTV devices, it's about all the IoT devices. How can we identify infected devices? And as I said before, we can do that using several tools. First of all, we monitor the traffic that goes out from those devices. So let's start with the device is already infected. So we need to accept this fact. Once the device is infected, let's say there is a bot inside this device, the device will try and communicate with the CNC, with the bad URL, and we will see that. We will see that in our tools using our threat cloud, using our security gateways. And by doing that, we can tell, okay, listen, there is a device, just like a user in your network trying to communicate with a bad website. We will see that and we will tell you, listen, something is wrong with this device. There shouldn't be any communication from this device to this bad URL, so we need to block this device. Another thing that we are doing together with Checkpoint is looking for anomaly behavior. Think about devices inside your network. There is a normal behavior and there's abnormal behavior. The coffee machines shouldn't talk with the IP camera. Doesn't make any sense. So we can identify abnormal traffic and abnormal behavior, devices that started to work in a strange time during the night, a traffic burst that goes out from one of the devices. Again, security camera shouldn't send a PDF file to the network. So we will see that and we will tell you, listen, this device is doing something wrong and so on. So there is a lot of activity around that. Both ARMIS and Checkpoint developing a huge intelligence cloud base where you will going to have a huge knowledge that we collecting also from other customers. This is one of the advantages of Checkpoint. We are seeing thousands of customers who are using the same IoT devices, so we can start building a profile for those devices, what is a normal behavior, and then, of course, to identify the abnormal behavior. Okay, let me see if there are more questions here.
So it's just to add, I think we keep seeing the same question come up around NAC. I think it's an important question, and NAC is a great concept. It's very hard to implement because what NAC relies on is the actual accurate information of what that device is, and then the policy to enforce. I don't believe there's a Forescout and other people have been pushing this for a long time. I truly believe that you need someone who's a specialist in the actual asset identification space, and then to work with someone like a Checkpoint, who is one of the leaders, in the enforcement, one of the most, well-renowned, network vendors in the world. That's why I think this marriage works so well. So are we a NAC? No. But do the two solutions work in a NAC-like way? 100%. I think that's what you guys need to be looking at is a NAC can't fix everything, but a combination of these two products can really go outside of the NAC scope.
Okay. Okay, so Marcus, back to you.
All right, thank you. Thank you both Ben and your ARMIS team, as well as Isaac and Royce, right, for putting together this content for the session. I would like to thank our partners, ARMIS, in joining us for this call. And to everyone, please take care and stay safe. All right? Cheers.
Thank you.
Thank you.
Bye.